Okay, so what I want to do now is move to some exercises from the book to keep hopefully reinforcing this process. And then also remind you that later on we're going to actually use indirect truth tables not just to determine whether or not an argument is valid or invalid, but whether or not a set of claims is consistent or inconsistent. Now before we get to any of that though, let's just draw your attention here to the first set of exercises from 5.5. And in that first set of exercises, our problem number 2 there says the following: Q horseshoe N, and then this is true. And we are told basically that we don't know in this case what Q and N, well, sorry, we know that the horseshoe is true, but we don't know what Q and N are. And so the question is, can we figure out Q or N, their truth values? And so basically what we're asking ourselves in this particular instance is, how many ways are there to make a horseshoe true? So if you've got those truth tables memorized, of course, this is going to make this much easier. But in fact, since there are 3 ways to make a horseshoe true, basically your answer here is basically question mark, right? We don't know what Q or N will be if all we know is that the horseshoe is true. So perhaps not a terribly surprising answer there. But I do encourage you to work through that first set of exercises just to get used to this sort of backwards thinking here that we're going to be putting to use in the indirect truth table technique. Okay, with that then, let's go ahead and look at this argument here, which is from the second set of exercises, and that's really what you want to be focusing on. And also I'll let you know that I'll be taking you through that indirect truth tables guidelines sheet here as we work through this again, just to make sure you're getting the hang of this. So this is the second problem from the second set of exercises from 5.5. And as we know here, the procedure to begin with is always to make the conclusion false underneath the main operator, right? And what that means then is that in this case, the F would be true. So that's our first step. Then we take that value, F is true, and plug it in where we find it. F is true over here then. And then after we've done that, then we make all the premises true underneath their main operators. And so we do that as well. And I want to emphasize this. You always need to indicate the main operator value on these problems, right? And so the circle of the main operator value there will work nicely to do that. So the next step, step 4, right, again, is the most difficult or the trickiest because we have to determine, well, which of these premises is the easiest to work on. Sometimes that's more difficult than others. Also, sometimes it actually doesn't matter which premise you work on first. They're sort of we might say equally easy to work on. In this case, though, it seems like if tilde is true here, it's a slam dunk then to say that the E is false. And so we then plug in that value where we find it elsewhere in the premises. E is false right there. And so now what we're going to do is we're down to our last premise. We work it out. False, well, the tilde makes it true, and it's the tilde that's feeding in from the left, and then from the F here from the right. So we're looking at true, wedge, true. Is true, wedge, true, true? It is. And so, as we know here, kind of jumping down, step 8 says, if at any point in working on the problem you're able to get all true premises and a false conclusion, we can go ahead and declare this an invalid argument, right? If this can happen at all, it's an invalid argument.